Hi everyone, my name is Sang-Yoon Kim of Yonsei University. Like the other lecturers in this course, I'm with the EE department, and the focus of my research and education has been in the area of wireless networks. During 1 hour, I will try to give some brief overview of wireless resource and management. Well, let me start with the definition of wireless resource management. What is wireless resource management? Resource in communication, wireless communication means radio frequency spectrum, which is very much limited. So we have to use this resource, radio frequency spectrum, very effectively. Optimization means management. So management means we have to maximize the number of users in the wireless system utilizing radio frequency spectrum resources very effectively. So talking about the wireless resource management, I will try to answer 6 questions. The first question is, how does interference affect the capacity of wireless network? Perhaps you don't know the terminology interference or the capacity or the wireless network. So the understanding, the definition of these 3 keyword terminology, interference, the capacity, and the wireless network is important to answer the first question. So let me start with an example of the cocktail party cases. Well, have you ever been in a cocktail party before? Well, maybe yes or maybe not. Well, imagine you are in a cocktail party to celebrate something, your dissertation or your report finalization, whatever. And then in the beginning, you can talk to your partners with a low volume and soft volumes because your partner listener can hear you very correctly. But as time goes, as the guest arrives in the cocktail room becomes very noisy. So-called interference is generating by each communication pairs. So your partner listener actually can hear your voice or a signal correctly due to the increased interference that is generated by your other surrounded communication pairs. So in the cocktail party room, as time goes, noise or interference goes too high, and then no one can communicate. This is so-called cocktail party effect. And such cocktail party effect is very well used in communication textbook to example or to illustrate the case of huge interferences in the network. Well, the question is, if interference is actually going up, what will be happening? That was the first question. Of course, you may understand that when interference goes up, no one can communicate each other. So it is very difficult to talk to each other. So there should be some coordinator such that some conversation may be possible. Well, to see more precisely, we may visualize wireless network using a graph. That is in your next slide. Well, network can be visualized using a graph sometimes to mathematically handle or to analyze the network more effectively. Of course, wireless network can be analyzed by using a graph. If you use graph, we have 2 things. One is node, the other one is actually the edge. In a wireless network, node means transmitter. In a cocktail party, the speaker. And another node is actually the receiver, RX. In a cocktail party, which is who is your partner listeners. And the arrow, the directed arrow, means actually the wireless link, which is actually the wireless channel, which should be based on a radio frequency spectrum. So in the cocktail party room, you have transmitting node and receiving node and link, which is wireless link. So we can visualize cocktail party room utilizing such graph. For example, if you go to the next slide, perhaps you see such random graph. In the random graph, you see actually a connection of each node by wireless link. By definition, the random network means your partner listener is actually the selected randomly. That means each communication pairs are randomly selected. This is slightly different from cocktail party room. In the cocktail party room, speaker and listener is actually very close, and they are in a very close proximity. However, in a random network, mathematical forms, actually the transmitter and receiver is actually located in a random position. That is slightly different. But however, in any cases, we can visualize cocktail party room utilizing this random network. Well, the question is, if you increase the number of nodes or a number of speakers, in other words, number of communication pairs, then this will generate lots of interferences because they are using the same resources, same radio frequencies, generating interferences. At a certain level, no one can communicate. So this is actually by intuition we could understand. Well, question is, as node density increases, we know that capacity goes to zero. Well, at this point, let me define the meaning of capacity. In a wireless network, capacity means the number of communication pair that can successfully talking to each other. If their communication is failed due to large interference or some other reasons, then we count the capacity. We do not count it as a capacity. So capacity goes to zero means there is no one successfully communicate. So as interferences goes to increase, or as node density increases, like in the cocktail party room, capacity, the number of successful communication pairs will be approaching to zero. So due to the interferences, we think that capacity is going to be equal to zero. Well, this is very intuitively understandable. Our next question is there any accurate mathematical formula that we can understand capacity and interference relationships more concisely or more accurately? That is related to the answering the first question more correctly. So if I go to the next slide, there is some mathematical formula, which was actually originally published in the paper in the year of 2000, published in the Journal of IEEE Transactions and Information Theory by Gupta and Kumar. And if you look at this formula, it looks complicated. The formula itself is not that difficult to understand. The lambda is a function of n. Lambda means capacity. As I said, capacity is number of successful communication pairs. So number of successful communication pair is a function of n. What is n? N is node, number of nodes, or node density. How many number of nodes in a given area, or how many number of communication pairs? It's a function of n, and the function is actually inversely proportional to n multiplied by log n. So that means if you understand this formula, as n goes to infinity, then lambda goes to zero. And we understand that lambda is approaching to zero as n goes to infinity, but however, we can more accurately understand the formula itself. Well, there is another terminology here, C and W, and C is actually some constant, is very much related to the system characteristics like antennas and some other physical layer techniques or something, so which is given parameters. Whereas in W is a given frequency spectrum bandwidth. In the beginning, I said actually the radio resource or resource means frequency spectrum, which is very much limited. So W is a given bandwidth or bandwidth of one wireless link. So as W becomes larger, then capacity will be increasing. But in this formula, the authors, Gupta and Kumar, assume that C and W is given and unfixed. So this formula says that this formula gives more accurate answer to the first question. As n goes to infinity, lambda goes to zero with such formula. And in their original paper, they define the capacity slightly in a different way than the others. That is so-called the transport capacity. Transport capacity is actually the multiplication. If you look at this slide in the middle, there's a bits multiplied by meter. So when the Gupta-Kumar defined transport capacity, they are interested in number of bits that can be transmitted per second. However, they are also interested in the travel distance of bits. If one bit travels twice meters than the others, then transport capacity becomes twice of the others. So transport capacity, understanding transport capacity is quite important to answering the next questions in my other slides. But at the moment, just understand that the capacity is a function of n, which is inversely proportional to n. And as n goes to infinity, then lambda goes to 0. Well, this is actually the bad news for us, because in a wireless network, n is number of communication pairs. So people desire to communication more, and number of communicating people will be increasing. However, if they are sharing the same radio channel, no one can communicate. So this is actually the dilemma for us. The question is how we handle such large number of communication pairs while keeping this capacity rules here. Well, radio resource management is, as I said in the beginning, is to maximize capacity of the wireless network while utilizing frequency spectrum effectively. How we do that? Well, radio resource management is, in order to say it, is to control interferences. We understand what is interference using this cocktail party effect. Well, by controlling interference amount effectively, then we can maximize the capacity, or we can adjust it, or we can increase the capacity of wireless network. That will be the topic in my next questions and following questions as well. Well, of course, you can think of very simple resource management technique, even though it's not desirable solution. For example, if you can't communicate with others, like in the cocktail party room, due to huge interferences, the best or very simple way of resource management is to make capacity 0. That means the best way is to shut off. Of course, this is very simple and very actually the extreme cases radio resource management technique. Well, there might be some other cases. For example, there will be some coordinators in the room. So for example, the imaginary situation that the coordinator actually making some traffic controls, like this guy should communicate first and remaining will be staying there. And there will be some kind of round-robin way of communication, for example. Not in the cocktail party room, in the communication system, this is possible, for example. So such a kind of radio resource management technique will be possible to handle interferences such that maximizing, or in order to maximize the capacity of the wireless network. So let's go to answer such, to know a little bit about that kind of techniques. Let's take a look at the other questions following. Thank you.